Having skipped this question, which I want to verify, you can try it out too, but I'm just thinking about it. So now, of course, it can be solved. So now, looking at this right here. So, we could have solved this one really, but I will send the solution to this. Now you're looking at 5.4. So at 5.4, it says given cos 2p equals to 3 over 5 within this quadrant right here from 0 to 90 degrees. So this right here is the question. Given this, so how do we solve this one? Right? So we have to remember that cos is equals to I raised to cos, let's say cos 2 theta, right? So looking at cos 2 theta, what is the value of cos b as it is stated for 5.4.1? So cos, we have to start off with solving this point right here. Cos 2b equals 3 over 5, right? This is cos 2b, so this is cos squared b minus cos, we should have not skipped that step, but okay, let's not skip any steps. So it's cos a plus a, right, equals to 3 over 5, right? So this is equal to cos a first angle sine cos a second angle, right, minus sine a times sine a, which is equals to 3 over 5, which is the second angle. Therefore, it is cos squared a minus sine squared a, which is equals to 3 over 5, right? So with this being said, we have to find this point right here. So we can either go into this point right here of sine or cos. But looking at the point that we're trying to find cos, it would help us to change into cos only for this question. Whereas if we were looking for sine, we would change into sine. So what does this mean? Here's the point. Cos squared a sine squared a. So I'm not going to complete all the questions. I want you to also complete the others so that it could be also challenging and stuff. So now, looking at this, right, we can, since we are looking for cos specifically, we're looking for the value of cos, we're going to change it into cos only. So what this means is cos squared a minus, right here, this one here, this identity. So it's cos, cos a, right? We have to also pay careful attention to that one, minus 1, right? This is the identity of cos. Sorry for that, I forgot to add this point. This only applies to this point here, which is cos 2a, right? So now, looking at this point right here, it only applies for cos 2a. To b, we were looking at b. Sorry for this. B, as you have found, this applies for, these are the identities for cos 2b specifically. So now we will look at this point right here. So it's cos squared b, right, minus sine is equal to sine is equal to 1 minus cos. Sine theta will be equal to 1 minus cos. So this would be 1 minus cos b, not beta squared, right, is equal to 3 over 5. So with this being said, just pull it out of the brackets. So it's cos squared beta, b, minus 1, and then negative times negative is a positive. Cos squared b equals to 3 over 5. So this is right here. 2b, 2 cos squared b minus 1. Right? As we can tell, this looks like something. But it will just like take us back here at this point right here. So this is okay, these multiple ways of solving this one. So this would mean 2 cos squared b 3 over 5 plus 1, right? So 3 over 5 plus 1 is equals to, so the answer is 8 over 5. Sorry, 8 over 5. 8 over 5 is equals to 2 cos squared b, right? So right here we can divide both sides by 2, right? So this is cos squared b is equal to, within the brackets, 8 over 5 over 2, which is 4 over 5. So this is 4 over 5, right? So at this point, what we do is have to square root this point. Sorry about that. Square root this whole point. So cos b is equals to the square root of 4 over 5. So it will be equals to 2 over 5. So this is cos b right here. How did we come about this point? Was cos 2b equals 3 over 5, and then we moved over to this point right here, cos squared minus sine squared b.